in this problem, I'm charged with solving a rational equation, an equation that has rational expressions in it. So there is an equation, there's an equal sign right here, and I'm solving it, meaning I need to find out what x is equal to. Now, there's a number of different ways to approach this. I'm going to show you the way that I do it. So I'm going to start, as I do with most rational things that I'm trying to simplify, by factoring, getting things down into their basic parts to see if there's things I can cancel out. Because when I can cancel out things, it makes the problem easier. So I have x plus 3 divided by, and I'm going to factor this. This would be x plus 2 times x plus 4 minus 1 is equal to x over x plus 4. So that's about as much as I can really factor out of this. But what I'm going to do now is I'm going to find out what is my common denominator. So I'm going to look at my first term over here, and I have two parts of my common denominator. I'm going to go over here. I'm going to say one part is x plus 2, and another part is x plus 4. Now my second term is simply 1. So that's 1 over 1. My common denominator is 1. I don't really need to do anything. And then my third term over here is x plus 4. Well, I already have x plus 4. So my common denominator here, the least common denominator that I'm going to use to bust this fraction, is that x plus 2 times x plus 4. And I'm going to multiply that now times every term in this equation. So first I'm going to multiply it by this term. And I can see that my denominator is going to completely cancel out. So again, I don't want you to see that. I don't want you to think those are really gone permanently. But if those cancel out, that means this first part is simply x plus 3. Now that is minus, and especially when I see a minus sign, I start moving towards brackets and parentheses. I'm going to multiply my least common denominator times 1. Well, that's not too tough. That would be x plus 2, x plus 4. And that is equal to, again, I'm going to multiply it times this term right here. And these x plus 4s are going to cancel out. So it's going to be equals x times x plus 2. So in one fell swoop, I have been able to get rid of my denominator entirely. Well, now I need to work on this and start simplifying. So x plus 3, there's nothing I can really do with that. I'm going to leave that as x plus 3 minus, and in this bracket, I have two binomials. This is going to be a quadratic. It's going to be x squared plus 6x plus 8, and that is going to be equal to x squared plus 2x. Now, you might ask me, well, why did I bother to expand that? Why didn't I just leave it in factored form? And the reason is, once I saw that I was going to have a quadratic here, and I saw that I already had a linear expression here, I knew that I was going to end up having to combine like terms. And in order to solve a quadratic, I'm going to have to get everything on one side of the equation and set it equal to 0. So let's just kind of work on that, and then we'll talk about it just a little bit more. X plus 3 minus x squared minus 6x minus 8, because this minus sign goes to all three terms, is equal to x squared plus 2x. Now, once again, when I have a quadratic, I want to be able to solve it. I want to be able to find the zeros, and I have three tools I can use to find the zeros of a quadratic. One is I can factor. 2, I can use completing the square. And 3, I can use the quadratic formula, which is really derived from completing the square. But in order to do that, in order to do any of these things, I need to get the quadratic into standard form. ax squared plus bx plus c equals 0. I need to get a quadratic and set it equal to 0. That way I can use the zero product property to help me solve it. If I don't get it equal to 0, if I don't get everything on one side, I can't solve it. The only time I can solve it without setting it equal to 0 is if I didn't have a b term. And all I had was, say, ax squared plus c equals 0. In that case, since I don't have the middle term, I could say ax squared is equal to negative c, subtracting c from both sides. X squared is equal to negative c divided by a, and then I can take the square root of both sides. But in this case here, and in really probably most cases that I see, I end up having a b. I will have this linear term. So let's go back to what we were doing. I need to get this quadratic into standard form and set it equal to 0. So I have a positive x squared on this side and a negative x squared on that side. So I'm going to kind of move everything to the other side. So I'm going to add x squared. So I'm going to have now 2x squared plus 2x is equal to, let's combine some of these like terms here, negative 5x minus 5. So again, I can kind of want to keep my x squared positive, so I'm going to add 5x to this side, add 5 to this side, I'm going to add 5x to this side, I'm going to add 5 to that side. So this becomes 0, and this becomes 2x squared plus 7x plus 5 equals 0. And since I'm kind of a creature of habit, what I'm going to do is, I'm going to erase this 0. I'm going to take my 2x squared. And I just happen to like that on the left-hand side, so I'm going to set it equal to 0. So the first thing I'm going to do with numbers that are kind of this small, and I could go directly to the quadratic formula, or I could go directly to completing the square, but I'm going to try factoring it, and I'm going to use the surefire method, which if you don't remember that, there's a good video on it. So I'm going to take the a times the c, so 2 times 5 gives me 10. And are there factors of 10, which when I add them together are going to be equal to 7, and I can see pretty quickly that that's 2 and 5. So I'm going to change this to 2x squared plus 2x plus 5x plus 5 is equal to 0. All I did was change my 7x into 2x and 5x because of this over here in the using the surefire method. Now I'm going to group. So I'm going to group this, and I'm going to group that. And I have, out of this binomial right here, I can pull out a 2x. So I pull out a 2x, and I'm left with x plus 1. And I have a plus, and out of this binomial here, I'm going to pull out a 5, and I get an x plus 1, which makes me happy, and that equals 0. Because now I can undistribute this, and what I end up with is x plus 1 times 2x plus 5 equals 0. And using the zero product property, I can see that one of my solutions, I can see very quickly, is negative 1. And the other one over here, if I go 2x plus 5 equals 0, 2x equals negative 5, x equals negative 5 halves. And these are now the two answers. I have solved the rational equation. Now, as you know, it's always a good idea to check your answers. So you can go back into your original equation and check negative 1 and check negative 5 halves and see if they work in your original equation. But one thing I'm going to do to show you a little bit different approach is I'm going to graph it. I'm going to use my calculator to check it. So what I've done is I've taken my calculator and I have entered this half of the equation as my y1 and this half of the equation as my y2. You might want to pause for a second just to see how I did it. I'm in classic mode. I'm not in math print mode. But you have to see how I use the parentheses. So make sure that you know how to use the parentheses properly and set it up so that's right. And now I'm going to go zoom 6. Zoom 6. And the first thing that's being graphed is my left-hand side. And that's what that graph looks like. And here's my right-hand side. And I can see that I have 2 points where they intersect. One's right there, and one's right there. So let's find out where those intersections are. I'm going to go second, calc, intersect, 5. And I'm going to find my first intersection, which looks like it's somewhere between negative 2 and negative 3. So I'm going to set, well, first of all, I have my first curve is there. My second curve is there. I'm going to make a guess, no. And I find that my first intersection indeed is x equals negative 1. You see it there in the left-hand corner. I don't know if I can really, I'm circling it. I hope you can see my circle. So that's one of my intersections. Now I'm going to use the cursor here and move my x closer to the other, what looks like an intersection. And I'm going to do it again. I'm going to go second, calc, intersect. First curve, that's good. Second curve, that's good. I don't want to make a guess. Oh, it still gives me a negative 1. I'm not sure I can get to that one using this. I thought I could, but I might be struggling a little bit. Let's just see if I can get to it a little bit better here. Whoops. Sorry for wasting your time. Second, calc, intersect. I'm going to make it, maybe that's the problem, that my first curve wasn't in the right spot. First curve there, second curve is fine, yes, no. And it comes out negative 2.5, which is the same thing as negative 5 halves. So, I don't know, I think it's kind of easy to use your calculator to check these. I certainly think it's more fun, but you can do it algebraically and you can do it on your calculator. So there's a lot of stuff in that problem. There's finding common denominator. There's making sure that you're able to bust the fractions using the common denominator. There's quadratic equation. There's a quadratic formula. There's factoring. There's surefire method. There's using a calculator to check it. So a lot of richness in that kind of a problem.